So that leads to the theoroid, which is that, and I got this theoroid from talking to a winemaker in Oregon, and I was tasting some Pinot, and it said 13.9% alcohol on the label. And I'm tasting it, I look at him and I said, no way that's 13.9, that's way more alcohol than 13.9. He said, yeah, it's probably 15. He said, yeah, we're allowed to say, plus or minus. I said, no. And I said, well, why do you do that? Is that for marketing reasons? He said, yeah. And it's what I was thinking. It's hard to sell a Pinot that said the alcohol content was 15%. People expect Pinot to be 13.5. So that got to be this theoroid, which is that buyers' willingness to pay for wine, it depends on what it says on the label, and things it says on the label. So this is the price depends on what is stated, the stated alcohol content. It depends on what variety it is. It depends non-linearly on these things. It depends on that. It depends on what region it's from. It depends on other characteristics, actual characteristics of the wine. And so the producer's profit maximising statement of the alcohol content is going to depend on all those things. And so then the producer has the problem that he's got to choose between telling a lie, and lying is costly in some sense. If you're an honest person, it's just uncomfortable, or you might get into trouble with somebody for telling lies. And you get the other penalty is being away from your optimum. So there's two costs: cost of being not at the optimum, and cost of telling a lie. And I assert a quadratic cost because I know what happens when you do that. And so you say, well, the solution then is to what the stated alcohol content is going to be a weighted average of just a linear combination of the actual and the desired. And so then we can substitute this solution to the optimum. This is just like other things we've seen a lot in agricultural economics. We can substitute this into the equation for desired alcohol, and we get this model, implied model that says the discrepancy is going to depend on the actual alcohol content in this particular way and these other characteristics. So we now can fit this model and we can estimate this beta, which is a measure of how honest you are. If your beta is 1, very honest. You put all of the weight on the actual and you just say the truth. If your beta is 0, you don't care what the actual is. You put all the weight on the desired. You just tell people what they want to hear. And so we can estimate that, and that's what we do. So another regression looks just like the other one, except this time the left-hand side variable is the alcohol, stated alcohol content, the discrepancy, and so we've got all these country effects. I'll skip that. We end up with this one. This is the one we like, where we've got country-specific trends and so forth, just like before, many of which are significant. And the model fits okay, and we've got this coefficient on the actual alcohol content. So everything here is highly statistically significant. It fits pretty well, and it makes kind of sense. And this coefficient on the actual alcohol is 0.274, which means that the beta is 0.726. It's closer to 1 than 0, so people are somewhat honest. If it was 1, they'd be totally honest. So that's interesting. And so, having estimated that thing, we can infer what the desired alcohol content is for each of these places. This was a transformation which you don't need to understand, you just have to trust me. And so we can say here for France, their actual alcohol content is 13.1, their recorded average was 12.99, and their desired is 12.7 for red. And for white, their desired is 12.5. And so we can fill up the table, and for the old world guys, their desired alcohol for red is about 12.8, and for the new world, their desired alcohol for red is 13.2. It's about 0.5% higher. And for white, the desired number is about 0.5% lower than for the red. So it's kind of consistent with the gross patterns in the data. And you get some variation among countries. You get this variation even though we're holding it's the same beta for everybody. We're saying everybody's the same in terms of their propensity for telling the truth in this model. Everybody has the same propensity, but they're different because their actual content is different. So this is kind of summarising all that. This makes sense to me. I mean, it's plausible. It's what I kind of think. I expect a good French red wine to have around 13% alcohol. So there. I presented this stuff in Italy one time, and so we estimated some other models. I'm not going to show you the other models, but we can estimate a different beta for every country and every year. We've got enough data to do that, so we did. And this is a table of those numbers. And so if you cheat, you'll spoil the fun. But if you look at this thing and you say, well, which country is which? I was doing this in Italy. And I said, who do you think? Now look at these ones in the middle. They're pretty honest. These ones on the left, they're big lies and they're getting worse. They started off pretty honest, 0.8, and they've gone to 0.6. And look at these people in the middle. They've been pretty honest all along. And look at these people on the right. They lied all the time. Who do you think they are? And the Italians are very nice people. They didn't murder me. But in fact, Italy were the honest ones. And the big liars were Argentina and the United States.
Are you voting for Berlusconi this weekend?
I don't vote in Italy. So we do that for everybody, and I think it's kind of interesting that the big liars, it turns out, one thing that's common among the big liars is that I shouldn't use this language, it's wrong, but the people with small betas, is that they are either Spanish-speaking or formerly Spanish-speaking. So Spanish-speaking countries in California are the places that have a big propensity for a small beta. So
lots of Mexicans in California.
Well, Spanish monks started the lying in California. So it's something else. This is not in the paper that you can get on the web about this. Doesn't have this stuff about the country-specific betas. And we've got some more data from the Liquor Control Board of Ontario, courtesy of George Saladas, for a smaller data set. We've got, I think it's, how many now? 18,000 almost observations, for which we have a price for each bottle, as well as the other information. So one of my theories is that price matters, that if it's this issue about the 50-cent tax, you're going to behave differently in that part of the scheme than if it's than if you're a very expensive wine. Or there may be something else. If it's maybe this Parker story is really about premium wine. It's not about bag-in-the-box wine. Maybe so it's not a very precise theory, but it's a loose idea that maybe price matters, and it does. So we ran one regression where we just included price as a variable. But this one we've got categories of prices, and so the default category is $10 and less per bottle. And so this first coverage is 0.077. That says if your wine is $10 to $20 a bottle, then your alcohol content will be higher by 0.077%, and your propensity for lying will be higher likewise. And these numbers just get bigger. As the price of wine goes up, these coefficients on price get bigger. So the higher the price of the wine, the bigger is going to be your desired and stated alcohol content. So that's kind of consistent with some of the story. Okay, so I'm nearly done now, so why am I showing you a picture of cake? So this is a carrot cake from the Nugget supermarket in Davis, actually. So I noticed something else, that but there are other things, other places where people lie. I don't know if you can read this, but this is a compulsory food label for carrot cake, and it says the serving size one slice is 4.5 ounces. I was in Canada, and I was in this hotel, and they advertised in the restaurant in this hotel for dinner carrot cake, one slice, and it was only a pound. It was a whole pound of cake was a standard serving of cake, and that's a pretty big piece of cake. I saw somebody eat one day. It was ridiculously large. Anyway, carrot cake is fairly caloric, and this is just the serving size of what that is. Okay, and then I see this cake from the supermarket. It was $2. The stated weight of that cake was 7 ounces. The actual weight was 13.2 ounces because I weighed it, and so in fact somebody who thought they were going to get 805 calories and pay $5.69 a pound for their cake would have got 1,518 calories, but much cheaper cake. There's only $3 in.
And there's the externality of the gym fees.
Well, they've got that. So the idea here is there are kind of two prices. It's like with the wine, you know, one price you're paying is the alcohol, another. So this one, you're paying two prices. You're paying for the food and you're paying the caloric burden as well. And so poor old Kabir, so I went and did this. I took my scale, and the guys in the supermarket get a bit odd when they see you weighing their food and taking photographs. So I sent Kabir to do it instead. And,
you didn't buy it?
No.
That's right. I'd assumed you'd taken it back to the lab.
No. Well, actually, we did buy some because we wanted to see. One theory was that this stuff shrinks with time, and they're taking insurance against that. But that piece of carrot there, that was one we did own. That one didn't shrink at all. It held its value for about 2 weeks. It just sat there. So we measured these things for different chocolate cake and carrot cake and things, and highly statistically significant consistent errors, consistently way understating the amount of cake in the box, and therefore overstating the price and understating the calories. We looked at some cookies, same thing, large errors. And so somebody said, well, you know, the supermarkets are just protecting themselves. These things are hard to measure. Nobody's going to sue you for being generous, but it turns out if they want to, they can measure things. So they can measure ground beef, which is just about as hard to weigh as cake, I reckon. And they pack it and they weigh it. They've got a unit-specific weight. And beef is more, cake is more expensive than beef, by the way. It's not that reason. So this is all quite mysterious. But they can actually weigh beef very precisely. And so I think they could apply that technology to cake if they wanted to. And they can get the bread right. They get the bread almost exactly right. So that's a bit of a mystery. So conclude that this seems to me this rising alcohol content is not something that wineries want. It's a nuisance byproduct of them doing other things they want, and maybe a bit of a role of climate, but not much. And the majority of cases, the alcohol content is higher than they wish, but not all. And they seem to systematically distort what they say in a way that's consistent with this theory that they perceive that the consumer wants to be told that this wine has certain characteristics. So it might be that, well, I've got a theory I haven't quite worked out, that why consumers pay wineries to lie to them about what's in the bottle. It seems that this thing in the supermarket, there may be lots of other parallels for this too if we start looking around. So that's the end of that.